All right, class, welcome to statistics. This is, we are starting with the textbook here. These are PowerPoint slides as we go through them, and we will go through all of them. First things first is I'm going to put more stuff in there that you need to write down. So sometimes it's the cover of the textbook. Usually if it's chapter 1, I will kind of give you the title for chapter 1. If you want to write that down, that's fine. Usually students don't, but it's just the intro. So this is chapter 1. Introduction to Statistics. We're going to cover these 3 things here. Don't need to write this down. It's not highlighted. But just in your mind here, overview of stats. A whole bunch of definitions right now coming at you. Okay. 1.2 is how we classify data as it comes in. What is data? How do we classify it? Are there numbers? Are there labels? Are there other stuff like that? And 1.3, data collection, how we actually collect the data, or how do we design an experiment that actually makes sense? Okay, don't write these down. Next is anything that's highlighted. Now you want to write stuff down. So I've got to be yellow highlight. If you want to put down chapter 1, I guess I should highlight chapter 1, Introduction to Statistics. I guess, right? That'd be at least be appropriate. So let me do this here. I'm going to go this way. I'm going to highlight. Change my mind. That's cool. I get to change my mind. I'm the instructor. Okay, there it is. Chapter 1, if you want to write that one down. And Introduction to Statistics, if you want to write that down as the, I guess I will highlight those because it makes for order. Boom. Okay. Now we're good? All right. Covering this stuff here, let's jam with 1.1. Overview of statistics. As stated, we're going to do a lot of definitions here. What is what? All right, what I normally will do is I look for people that are done. Their pins are kind of down. They're not writing anymore. If I see people going like this still, I'll wait a little bit longer. If I go too fast and then I don't see your pin or your hand, just tell me, Mr. Energy, can you go back? You no problem going back, okay? All right, let's jam with it here then. First things first, before we even start to look at what is statistics, we gotta look at what in the heck is data. And data is any information coming at us, either from observations, sometimes we're just counting things, sometimes we're measuring things, and sometimes we have like a survey response of stuff. And one of the things I really like about your textbook is that a lot of the data that we have here is actually live data, which means they get it from somewhere. Is that a little better to see the board there? All right, so highlighted section is data. That's what we're going to work with. Any kind of information. And the 4 most common ones are observations from things, counts, measurements, or responses. So just a few here. According to a survey, more than 7 in 10 Americans say a nursing career is their prestigious occupation. Okay, health career science majors. There it is. That little blue stuff right here in parentheses, it says source, the Harris poll. So you know that these are actually live polls taken sometime. Okay. Okay. And if you finish writing it down, and if you want to just kind of read the non-highlighted sections, that's cool too. Just kind of give yourself an understanding of things here. I sometimes will mention them. I sometimes won't. There it is. Social media consumes kids today as well. More score than first social media accounts at an average age of 11.4 years. Is that true? I don't think that. I think that's not true anymore. I think it's way younger than that right now, right? Because I see people shopping in the store and and they're kids that are not even walking yet, inside the little imaging, they're sitting in front of a screen. Seen those? That's like, dude, that's like a year, no, 2, maybe 3, right? 3-year-olds. Their encounter is looking at a screen while their parents are shopping. So, don't know. And then sometimes statistics are kind of dumb. Because I seen a stats I was reading about, and it said exposing your kids to scary movies before bedtime does not allow them to sleep restfully. It was a conclusion from a university, and it was a whole semester study. And one of the things was it took $20,000 to do the study. And so, yeah, ask a parent. That would have been so much easier, right? And so, kind of sometimes those questions that we ask ourselves are kind of dumb questions, right? And really, the point is like, what do you really want to investigate? What do you want to find out on a very thoughtful basis? I think we do this a lot, though, don't we? In our minds. Don't we think that certain things are true and certain things are false? That's how we make decisions, right? Like, hey, this is going to get me to this, or I think this is the best road this way, right? We do think this way in our minds, except sometimes, like in statistics, sometimes we actually do need concrete measurements of things, right? And so stats, so if you think to yourself, hey, I'm going to go to West Coast College as opposed to another college, you're probably not going to do a statistical study on it, right? You're probably going to find out some information, right? Do they have scholarships? Do they have, how expensive it is to go, right? You kind of gather this data, right? And then based upon that, you make a decision which way you want to go. And that is a type of statistics. It's not hard stats, right? But it's soft stats. And then you have a COVID pandemic on your hands, right? And at that point, you don't want to like, hey, I think we should do this, right? At that point, you do want to say, hey, I wanted to see some numbers. How does this work out? Is this true? Is this not? And so at that point, then you're thinking, okay, serious nature, I think you want to go with it. But that's kind of the difference there. And so as humans, we are inquisitive creatures, so we do want to find answers to stuff. This is one of the ways we do it. Okay, enough of that. Let's go with it. Statistics, finally, what is it? Sorry, go back. So stats is a science. Science just means it has some kind of method with it. It's a method of going from one to the other. Science of collecting first, organizing. I almost want to say displaying the data as well, because that's part of stats, displaying the data. But analyzing the data, and then eventually interpreting the data so you can finally make a decision. As I said earlier, right? That's exactly what we do, right? The reason why you chose to go to West Coast College is because you found that choice better than another choice, or not going to college at all. Good to go. Okay, tell me if you need more time. Otherwise, and raise your hand or just say Mr. H. That's fine too. Okay, stats. Here it is. Yep, you organize something, you get some data, you think about it, and then you make a decision based upon that interpretation. Okay, so the two things that we do, we got to think of a distinction in our data. One is having to deal with the population. Population just means you have all the information in front of you. of the population that you're looking at. So it's the collection of all the outcomes, all the responses, all the measurements, all the counts that are of interest to that population. So who are you talking about? And are you able to get all that data? Sometimes you are. That's cool. A lot of times is what we do is we deal with sample sets. It's going to be some kind of group that is part of the population. Okay, we're good. Population. Let's do this one here. I'm going to just call him Kyle. I don't know if I can name Kyle. And so Kyle is the person that heads all the data at the district office of West Hills College. He has access to everything. So if he's interested in the GPA of all West Hills College students, like, hey, you know, what is the average GPA of students at West Hills College? His population is students at West Hills College, right? Does he have the data to get to it? Yeah, he goes on his computer, right? And he clicks a little button, GPA roster of all the students, and he clicks average. So he's dealing with the population because he has access to all that information. Sometimes we can't have access to all the information. So let's say, oh, this is a good one here. Since today's election day or recall day. So yesterday, people were polling, right? They don't have access to every single person that's going to vote, right? So what they're doing is they went out and there was phone calls made and like, hey, who are you going to vote for? Are you going to vote for the recall, yes or no? So they're just getting a sample of the population. Okay? And so talk to me. Is it easier to get the population or is it easier to get sample? Way easier to get a sample if you're talking about a large population, right? If you're talking about confined population, so it almost like sometimes matters of what you're trying to do, right? That's all. Okay, GPA of West Hills College students, easy access to get population data. Voting data, not so easy. So we have to use samples. Now, because we have samples, we have to understand we have to have different formulas for sample stuff as opposed to populations. Okay, Jim, are we good? Right here, don't need to write anything down. This is kind of sort of think about and do it real quick here. So we have in the recent survey, 834 employees in the United States were asked if they thought their jobs were highly stressful. Of the 834 respondents, 517 said, yes, my job is stressful. Identify the population and the sample, and then also describe the sample data set, or should you say the data set? Talk to me here. Anybody, what is the population in this survey? We got 834 employees. I'm going to say no on that one. So what information are we trying to get of which population? I know that. How about all the employees in the United States ever? We're not saying ever, but all the employees in the United States. Is that right? That's the population? We're trying to figure out if jobs are stressful or not. So all employees, could we ask every single employee in the United States? Is that tough to do? Yeah. So what's the sample set here? 834 employees, right? Those are the ones that were asked. And the sample data is that 517 said yes, right? And then however many said no. And I'm not sure if there's a third option. Did some not respond at all, right? Yes, no, or maybe, right? Or sometimes. So there it is. We're good there. So population consists of all the employees in the United States. Sample set were just the 834 that were surveyed. And sample data, of course, it's a subset of the population, but the data set is 517 yeses, and assuming there was only a, what's called a bimodal survey, which means yes or no, that's it. Assuming that you got 317. Okay, we're good then. So it's what you want to know and what's the overarching population. Okay, jam. So now let's talk about the data itself. When we talk about the population, we're getting data about the population. What we do is we call it a parameter. Sometimes you say, hey, what's the parameter here? So a good example, maybe just average age of all people in the United States. That's a population parameter. You're talking about the population and you're trying to figure out the data of the population. Then you have something called a statistic. Statistic then is going to be a numerical description or data from the sample itself. So instead of doing all of the states, only 3 of the states. Somehow those states kept better data. We were able to figure out better data. So in this case, that's called a statistic. So parameter deals with population. It's kind of cool that they start with the same letter. And a statistic is sample data. All right, so let's go with it here. Let's distinguish between a parameter or a statistic. Here we go. So a survey of several hundred collegiate student athletes in the United States found that during the season of their sport, they are spending about 30 hours a week on their sport. That's true. There it is. Source is, I'm not sure that we've seen that source before. But you guys talk to me. Is that a population parameter or is that a sample statistic? Let's do this here. Raise your hands. How many say population parameter? Of course, Mr. Najib. How many say sample stat? Mr. Najib. Raise your hand if you're not sure at all. Okay, that's cool. Okay, raise your hand if you're still asleep. Okay, that's cool. Okay, so let's talk about this here. So a survey is done, right? Who are being surveyed? Yeah, several hundred collegiate student athletes in the United States. So hold on. So there's a few hundred that got surveyed. And I'm thinking, okay, is that the population they're trying to think about? Is it just those people, or do you think they're trying to get information on all the student athletes in the United States? Yeah, thinking eventually they want to get information of all the student athletes in the United States. But they only surveyed several hundred of them. This guy would have to be a sample statistic. Does that make sense, guys? And usually, yeah, no, you can't even say that. I was going to say, usually we do a survey, but you can't even say that because you could survey everybody. Okay. It's a subset of the population. The population is all collegiate athletes in the United States. Okay, how about this one here? University wanted to figure out what was the average SAT math score for their students, and it turned out to be 514. And it's the freshman class of the university. So someone got in to the computer system, looked at freshmen, and got their average SAT score. Population parameter or sample statistic?
Sample statistic.
Cool. And talk to me, how come you guys, how come some people said parameter. Okay, so they say that's a whole freshman day. Seems like they don't want any information beyond that. It's just that's what they did. Anybody has a sample statistic why you said that? Go ahead.
Because it's a sample right out of all students.
Gotcha. Okay, that's cool. Let's go with it. You guys, this is what it's all about. We have conversations, we talk about it, and we go from there. Thank you guys so much, you brave souls, for saying what you think. That's awesome. Okay, so let's see. Are they trying to? Does it seem like they're trying to get SAT data for everybody in the United States? No. Does it seem like they're trying to get data for everybody at the university? No. Does it seem like they just want data for the freshman class at the university? Yeah. They just pull up all the data for the freshman class at the university. Yeah, so there it is. I think if it wanted to do population, it would say the university wanted to find out, right, their average SAT score at the university. So they pull the data for the freshman class. Then you're talking about, okay, that's a statistic. But here I'm going to go with it's a population parameter. We're trying to find out the freshman class SAT scores, and we found the freshman SAT scores. And that's important for universities usually. If you look at universities, what they'll say is like they have the last 3 years of SAT score averages they entered the university. That's kind of but they, after you get into your sophomore year, no one cares because you got it right. Okay. All right, how about this one? One more. Random check of several hundred retail stores. The FDA found that 34% of the stores were not storing fish at the proper exact temperature. Okay, raise your hands. Here we go. How many say that is a population parameter? At a half a hand. Yeah. How many say a sample statistic right here? This is sample. Okay. Boom. And then the other part of you guys are not sure, I assume. So let's see. As I'm thinking about this here, it looks like they did a random check, right? Random check, and they checked several hundred retail stores. So it seems like they didn't check every single retail store. They just checked several hundred. And they found out that 34 of those stores did not store properly. Their fish at a proper temperature. So, okay, so then I'm thinking, okay, what are they trying to do? What's their trying? I think they're trying to figure out if fish are stored at their proper temperature in retail stores. But once I say that, then I'm thinking, okay, hold on, that means all the retail stores in America. And if they only check several hundred, it has to be a sample statistic. Okay, are we good there? All right, and one final thing before we finish up 1.1. The two branches that we're going to cover here. So descriptive statistics, that's chapter, if you want to write down chapter 2 on there, that's fine. But we're going to get the data. We're going to try to figure out how to organize the data, summarize the data, we're going to display the data.
This is chapter 2.
No, this is kind of like an overview of where we're going to be. So the two branches of statistics we're going to cover is descriptive statistics, and descriptive statistics is chapter 2. We're going to take one chapter to study that. And then we're going to jump into inferential statistics. And that's going to be chapters 6 through 10. I'll write down chapter 6 through 10. So what does that involve? It involves usually a sample set. Oh, sorry, it does involve a sample set. And once you take a look at the sample set and you crunch the data on it, you analyze it, and then what you're going to do is you're going to draw conclusions from the population. Practice on. So if you want to put a little notch next to it here, again, chapter 2 is right here, descriptive statistics. That's going to be chapter 2. We're going to take care of a whole branch of statistics in one single chapter. That's awesome. And then differential stats is going to be chapter 6 through 10. Chapter 6 through 10. Take care of that.
Descriptive statistics is chapter 2.
Uh-huh.
Chapter 6 to 10 for differential.
Uh-huh. 6 through 10, yeah, 6 through 10. You could say 6 through 11, because the rest is book, but 6 through 10 is what we're covering. All right, so we're missing 3, 4, and 5. Is that right? What is 3, 4, and 5 again? We're missing 3, 4, and 5 are gone. There's chapter 2 there. There's chapter 6, 7, 8, 9, 10.
Oh, but we said we were gonna skip. You said we didn't have gap.
Little gap. What was the gap called? Started with a P. Probability, right? Probability, its own little universe where we're going to study probability in chapters 3, 4, and 5, which is not statistics. It's just probability. It's a different thing. Okay, let's jam with this one here. So, let's see. Let's identify the population. This is the homework question as well. So identify the population, and then also the sample, and then figure out any conclusions you may draw from it. So here it is. A study of 2,560 U.S. adults found that of adults not using the internet, 23 are from households earning less than $30,000 annually. The figure. So here's a figure there, and here's kind of like what they said about it. And so 23% of the people that are not online are earning less than 30 grand. Let's see, even though there's more stats here, right? There's your stats, but then here's they're talking about it right over here. So talk to me. Identify the population. Anybody? Who are we trying to think about?
US.
Yeah, U.S. adults. That's what we're talking. Not kids, not teenagers. Just U.S. adults. Population or the sample. What's the sample? Absolutely, 2,560 U.S. adults, because we only talked to them, right? We only sampled them. And then, what conclusions actually were drawn by the study?
20%.
Absolutely, 23% for households that don't have internet are coming from households that are earning less than $30,000. Is that true of the whole U.S. population? Could be, I don't know. Right? That's kind of where we talk about is the fact that, first of all, I don't know if 2,560 U.S. adults represents all the adults in the U.S. well, right? I'm not sure if that's represented well. I'm not sure if the data is skewed. I'm not sure if the person only pulled a certain amount of people or a certain region as opposed to trying to figure out how to get a good sample of all U.S. adults. Right? So all those kind of things come into play. But there it is. So we are done with 1.1. All right, class, we are in 1.2. Myself. Okay, so now let's jump to data classification. How do we classify? What kind of data do we have? So in the previous section, you guys remember we had like what? We had like surveys, measurements, responses, all that constitutes data. So now we're going to classify the data itself here. So let's go with it. So data classification. First things first is qualitative data. Qualitative data just means not numbers. Consists of attributes like major, like I asked you guys in the beginning class here. Birthplace would be good, eye color. So qualitative data just kind of distinguish it. Like we have non-numbers and then we have numbers. There's your two big distinctions. Then we're going to jump to the different classifications. And 1.2 is really a quick little section. Quick little section to look at. Almost like goes without saying, right? We have non-number data and then we have number data.
So not numbers, or like,
Yeah, non-numerical entries. Yeah, that's the big word.
no numbers.
Yeah, these guys, yeah, qualitative data, whenever you say like, oh, this is qualitative data, you're saying there was no numbers associated with it, no numbers in the data set whatsoever. Cool, okay, and then qualitative data, that's just qualitative means. And then jump to quantitative data. Now that means we do have numbers here. So some kind of numerical measurement of something. Some kind of count. We counted something in the process. Here's age, is a good one. Weight, letter, temperature, all that, just any kind of numerical data. There it is. It's called quantitative data. Qualitative versus quantitative. There's your two things.
Only two types of data.
Now we're going to go into levels of measurement in just a bit here, but just in the onset, just as like the big wide things. Look, you have sometimes you have just categorical data, sometimes you have numerical data. There's your two sets, and then we're going to jump into sometimes it's depending what you're talking about. You may have two things. Let's see. Sometimes data comes together, right? And sometimes we have data that's some of it is quantitative, some of it's qualitative, right? So that's kind of just the way things happen. So let me jump to like something like this right here, right? So you have a table gives you sports-related head injuries treated in emergency room. So there's basketball is 130,000. This is emergency medicine data, so I assume it's the United States, I guess. Baseball has about 83,000 per year, roughly. Football, 220,000, and so on and so forth. Easy stuff, right? One of them is qualitative, one is quantitative, right? The left side is qualitative data. It's in terms of types, it's non-numerical. Then you have numerical data on the other side. So there's your two things. Okay, now let's jump to going one level deeper. Okay, so this is the way we classify measurements of things. First things first. We say nominal level measurement. That statistics, that stat involves only nominal level measurement. So first things first, nominal just means naming things. So it's qualitative data only. It's qualitative data. That's it. That's all you get. It's just some kind of categorization of stuff. You can't do any computational measurement with it whatsoever. So it is hair color. It is makes of cars. List of all the community colleges in California. Nominal just means you name something. Then we have something called ordinal. And I like to kind of think about it as order. Now you can put stuff in order. So first things first is it could be actually qualitative, could be quantitative. You can put numbers in order. We actually can put categories in order as well. But somehow this can be arranged in order, or they can be ranked according to something. So The last part there, differences between data is not meaningful, which means like if it's ranked number 1 and it's ranked number 3, number 3 doesn't mean 3 times bigger. There's no we call it ratio value between the two. So how about this here? Verbally speaking, here we go. Community colleges in California. What data would that be? Starts with an N. Nominal data. Now if I just change it around, ready? If I say community colleges in California with the highest graduation rates. Yeah, I just turned that into ordinal data, right? Now I'm actually ranking them according to some kind of criteria. Cool. Awesome. Lots of writing. Anybody think of another example here? Give me a nominal level measurement, or give me an ordinal level measurement. And not from the PowerPoints. Let's talk. Okay, so nominal just means it's like any category whatsoever. So maybe a good example, I said, was just a list of community colleges in California. Right, it just kind of just names, right? Or like hair color, right? Oh, there it is. There's no connection between the pieces, they're just categories. But if you start ordering them somehow, then you just moved into ordinal data. So anybody give me something that you can order. Give me a rank of. Eye colors. Eye colors would still be nominal, right? Because you can't rank eye color according to something.
But if you were to say like how many people in this room have like brown eyes?
Yeah, that would still be nominal. Because you're just listing people into categories.
The best insulation.
Second.
The best insulation.
Say a little louder here because our
The
weird
best
stuff.
insulation, right?
What's he saying again? Sorry.
The best pencil that you like.
Oh, the best pencil. Yes, call ordinal data now, right? Boom, there it is. You kind of put it in order. So movie genres would be nominal, right? And then if you say what is the most popular movie genres, you just moved into ordinal data. Because now you've given them some kind of
What's the best sport?
best sport, ordinal data, right? Or just sports. That would be nominal data because you're not having any connection. Okay, we're good there. Sweet, I think we got it. You guys, thank you so much. That was an awesome teachable moment. We actually are talking. This is great. Okay, so jam with this one here. So it gives you the one that is nominal data. Nominal, name only.
So movie genres?
Movie genres, right? There's no order to them. There's no nothing. It's just listing categories are done, right? Ordinal data is number 1, right? Because that's now the top 5 of this one. Now you're actually ranking them somehow. Now, that's what they're saying. The last piece of there, it says that the differences between data are not meaningful, which means like number 1 and number 2 doesn't mean number 2 is twice as big as number 1. Doesn't mean that at all, right? The order ranking or how popular they are is not an issue. But the fact that you can order them, that's it. You got ordinal data underneath. Okay, we good there? Cool, cool. Next, we jump to this one. That's the one I should have showed you right there. And then let's jump to the next one. Interval level of measurement. That means. So once you get to interval measurement, first of all, it's only about numbers. But numbers come in kind of like 2 different ways. This is kind of weird with numbers. interval level measurement is, it's quantitative, which means deals with numbers. The data can be ordered, that's great. Now there is actually meaning between the data points. So if a number is higher, it actually means something that is higher. Now this is the weird thing right here at the end. Is it the 0? It actually represents the position on a certain scale. But it does not mean that 0 means nothing. Okay? Sometimes we mean 0 is nothing. Sometimes we just mean it as a position on a scale. So let me give you the other one. We'll kind of talk about 2 different ones here. Okay, good. There's 1. So 0 just means position. Okay, let's go with it here. That's called interval data. So the big thing is it deals with numbers, but the 0 does not mean nothing. 0 just means somewhere on the scale. Next one, the ratio level. This is the last one that we're going to do. It's similar to interval. That's cool. Except now, 0 actually means nothing. 0 means we have nothing in there. We don't ever actually think of those distinctions too much in life. The other thing we got to think about is this: the ratio of 2 values can be formed, which means if one value is 10 and another value is 20, 20 is double 10. This one's the one that ratio level is the one that we are more comfortable with. We use this all the time, or almost all the time. So like number of enrolled students in MATH25. If it's 0, class is not going to function because there's no students, right? So 0 actually means nothing or nobody. Cool. So let's go back. Let's go back up to, oh, sorry. Okay, go ahead, finish up writing. And then, so can you guys give me another example of ratio level? 0 means nothing. Go from there. And ratio, the word ratio actually just means that like, if you have like triple amount, you would have like 30 instead of 10. That's kind of what ratio means there, right? That's one. Then also 0 means 0. Kind of the language between. Number of computers sold at a computer store. Okay, that's a ratio. Number of chairs in the building. Cost for equipment. Those are all ratio levels. And that's the one we use this almost all the time. Okay, you're good? Let me jump backwards here. You guys finished writing? Tell me if you're not. Let's jump back to interval data. Give me a numbers, but then when you get to 0, 0 does not mean nothing. It actually means something. It's usually like a scale. The weather. Weather's perfect, right, guys? We have something that's called 0 Fahrenheit, but that means you can still go lower, right? 0 doesn't mean like you have no temperature at all, right? That's interval data. Temperature is a good example. Anybody else with a good example? Good. Let's see. Because I'm married to my wife, I know there's something called zero size dresses. But doesn't mean there's, right? Doesn't mean there's nothing, there's no dress there, it just means there's zero size, right? And so there's that.
What is that zero size mean?
Ian?
What does that zero size mean?
Yeah, ladies, what does zero size mean? Like very, very petite, very small. Almost like juniors, but not junior, right? It's like ring sizes, perfect example. Okay, absolutely. Shoe size. Shoe size would be example, right? Because you have like a 10 size shoe, and then you have 5-foot shoe, but doesn't mean that they're double the size. It actually means there's just a scale, right? We never get to zero size shoes, do we? Because we go into like men's or women's, right? And we go into toddler, right? And we kind of do it that way. So, but they're all just scales, right? They're not really a measurement. Okay, let's jam with it.
He said, look, bro, you have zero vision on one eye. You have a zero vision on the left eye and you have a 20 on the right. And I'm like, so you need none on the left. He's trying to say that it's a wait, what's it called? Not a ratio.
I'm gonna let that go.
Does it make sense?
So zero, let's see, transparency and vision, if you say zero, now 20/20, that's a scale, right?
Yeah.
But with scales, you are legally blind when you have a certain level, right? You can still see, but legally you'd be blind at that point, even though you still have visibility. So we have difference of scale of eyewear versus visibility, right? Zero visibility means nothing. And so there's two things there with eyes, right? There's a scale factor, then there's actually a seeing factor. Yeah, and we judge it by both of those.
So it wouldn't apply to this case.
Well, actually, both are kind of mixed up together. They're having fun in college class. All right, that's cool. Let's go with this one right here. Tell me which one is ratio, which one is interval.
The interval is the years.
The years, perfect, awesome. So years also is a interval data, right? Because you can go BC still, right? But zero just means zero in a scale of years. And on the right-hand side, it's the number of home run totals. So in this case, if a sports club had zero, that actually means really zero. They didn't have any home runs whatsoever. There's a difference between the two there. Okay, are we good there? Does that make sense in classifying the data? Cool. I'm not sure if this is helpful or not. This is exactly the book, so I decided to put this in, but I'm not sure if this is useful or not. So this is kind of like the 4 levels versus what kind of data you can put in there. So this is, can things be categories? Can they put things into categories? Yes, all of these guys can be put into categories. Then can you arrange it in order? Well, nominal data, you can't arrange in order, but everything else you can. Another question is, can you subtract values from each other? Right, because ranking order, you can't subtract them, right? Intervals you can. And ratio, because if you're dealing with numbers, you're dealing with some value of difference between them. And determine if a data value set is a multiplier of another, so that means now 200 home runs is twice as big than 100 home runs. It's exactly twice as big. As opposed to, this is kind of interesting, we don't think about this here, but if temperature is 50 degrees and a temperature is 100 degrees, that does not mean it's twice as hot. Okay? We just have a scale factor of temperature. We just know that at 50 degrees it's kind of cold, 100 degrees it's kind of warm, right? So, but it's not twice the amount. It's just a scale. So I'm not sure if that helped out or not. There's some examples here. This is nominal data. don't need to write this down. It is in your textbook as well here. So just, they kind of gave you a lot more listing of types, which I found those. So TV shows by network, that's fine, but somehow it's, you're putting things into categories. That's what you want. Ordinal data, now you can order them. Hey, this is kind of cool. I didn't see this one before here, but how about this here? Motion Picture Association rankings, right? There's your rankings. Now there's a whole bunch more. As I look at Netflix and there's like Y17 and this and that, right? This is expanded out quite a bit here. Okay, so anything that you can rank. Interval data, temperatures, we already said that is a good one, right here, temperature scales. Anything that's a scale. And the ratio are, how about precipitation rates or number of rain, right? The 0 inches of rain means actually 0 inches of rain. And the other thing that sort of keep in mind is the fact that 2 inches of rain versus 1 inch of rain means you got double the rain. Okay, with that, I think we're going to be done with 1.2.